So what we're going to do with this problem, it says calculate the mass in grams of 23 molecules of H2SO4, sulfuric acid. Now, the first thing that you want to kind of get an idea of is, what am I going to need? Am I going to need Avogadro's number in this problem? Am I going to need molar mass in this problem? And what we talked about in class was that if you see words like molecule or atom or formula unit or particle, you're definitely going to need to use Avogadro's number. And if you see mass, grams, kilograms, you're going to need the molar mass. So I think probably the first thing that you want to do here is figure out what the molar mass of H2SO4 is. So that would be our first step, to figure that out. Alright, so when we look at H2SO4, we notice, first off, there are no parentheses, so we don't have to worry about doubling up anything or tripling up anything. We see there's two hydrogens, and when I look on the periodic table, I see that each hydrogen is 1.01 grams. When I look up sulfur, each sulfur is 32.07 grams. Let's go ahead and put grams so we don't get confused. And there's 4 oxygens, and each one of those is 16 grams. So I'm going to take all these values, multiply them out, and then sum them up. And when I do that, I get, let's see, 98.09 grams of H2SO4. Basically that means that I have 1 mole of H2SO4, and that's the molar mass. So I'm going to use this in my calculation to help me convert, because I have to solve for mass to get my answer. So if we set up our bracket system, we're going to say, okay, I'm trying to find grams of H2SO4, and I'm asked to find the grams of what? Well, it says in the problem, 23 molecules. So let's set up our lines here. Molecules is what I want to cancel out, so I know molecules is going to go on the bottom. And I'm trying to find grams. So I know grams is going to go on the top of H2SO4. And now I need a conversion factor here. Well, I know that 1 mole of H2SO4 is equal to 98.09 grams of H2SO4, which is also 6.02 times 10 to the 23rd molecules of H2SO4. There's a conversion factor that I can use. So my 98.09 is going to go there. My 6.02 times 10 to the 23rd is going to go there. I'm going to cancel out my molecules, and what am I left with? I'm left with grams. Over here, this is what I want to find, so I don't need to do any more converting. Now it's just a matter of multiplying and dividing. So I'm going to say 23 times 98.09 divided by 6.02 times 10 to the 23rd. So type it in here, 23 times 98.09 divided by 6.02, 823. And I get, and I'm going to do the 3 sig figs here, 3.75 times 10 to the negative 21st grams of H2SO4. Now, I always ask you guys in class, does the answer make sense? Well, we're asking to find how many 23 molecules has mass of, and that's going to be an extremely small value. We know that. Well, is this an extremely small value? Certainly it is. You take this decimal, you move it over 21 spaces to the left, you're going to have a tiny, tiny value for grams. So the answer makes sense. Anytime you're asked to find the mass of double-digit or single-digit atoms, particles, molecules, or really any molecule value like that, you're going to end up with a pretty small answer. The reason I did 3 sig figs here instead of 2 is molecules. This is only 23 molecules. That's an exact number. You can't have 0.2 molecules. You can't have 0.3 molecules. Just like you can't have 2.57 eggs. It's either an egg or it isn't. So molecules are exact, so I don't use them with my sig figs. This has 4, this has 3, so I rounded to 3. Okay? So 3.75 times 10 to the 21st, negative 21st grams is the answer.